Hi, everybody. Well, hopefully technology is working well and you can all see and hear me. I'm Toby Simpson and I'm here with Josh. We're going to be talking a little bit today about mobility. It's a grand problem and we have a grand solution for it. What we're doing here is delivering better mobility through improved autonomy in transportation. There is a little button at the bottom of this thing for asking a question. Please feel free to do so. We'll get to answering any questions that you might have at the end. It would be wrong of me not to start this by thanking Twitter for showing us the importance of decentralization and controlling your own private keys. One of the problems with centralized systems is that there's one attack point. And once you get in, you compromise everyone. And we see this all the time in finance and when databases of email addresses and private information and credit card numbers are leaked. Whereas in a decentralized system, each target must be attacked individually. And if the private keys aren't leaked, then security is guaranteed because digital signatures can prove that messages are original and untampered with. And I think that's a key demonstration, really, of why decentralization is so important. So let's move on by putting my mouse pointer in the right place and clicking. Right, okay, so briefly just first, a quick introduction to Fetch for those who aren't familiar with what it is we do. We are breaking the economy down into individual parts and bringing them to life. We call those parts autonomous economic agents, and they are representatives of things like data, IoT devices, services, people, anything. And they're able to act on their own behalf in order to get things done. We also deliver a search and discovery system, and this is an active connection of those agents that have something to those agents that need something. And we deliver AI across the board. Not only do we enable people to do AI through autonomous economic agents, but we also are building all sorts of aspects of machine learning AI into the system in order to better introduce agents together, for example. And the FET token, that is the fuel for agents. It's also the fuel for deploying smart contracts, executing smart contracts, for learning, and for much more. It's the value exchange mechanism between autonomous economic agents. All this code and everything we've done, it's out there, it's available now, the code works. Agents are real, the documentation is good and getting better every single day. And over the last 2 months, just as an example, some lovely stats there, that we've served over 105,000 agents, delivered 40,000 plus search queries, and over 150,000 individual agents have been found. And at one point we had 4,200 odd agents on the system connected to the OEF at the same time. And that was spread across a bunch of the use cases that we're doing, including the trains, which we've done a video on recently and we'll talk about again today, the ride hailing and much, much more. So what we're doing is applying this technology in this particular case to mobility use cases. We like to think that we've got a mobility solutions framework. It's a suite of tools, software that you can use, the Fetch network, to deliver mobility things. And these are things like, for example, last mile logistics, which is the complicated and tough issue of getting the package, that last few kilometers into your hands, or from the restaurant getting the pizza into your hands. Also, augmenting artificial intelligence for levels 3, 4, and 5 self-driving vehicles. This stuff is hard. And by bringing the world to life with autonomous economic agents, some of the things that are around you, signposts, junctions, other bits and pieces, can explain to the cars what they are, so that we reduce the load on traditional AI and bring a day when we can have true self-driving cars out there a little bit closer. We're also looking at delivering live context-sensitive push information to make your life easier. So instead of you having to worry about juggling everything, the information you need comes directly to you. And that can be used to feed machine learning-based insights through all this data that's available from all of these agents. And there are incentives for people to participate because, of course, if you have agents that represent sensors or other informational services, then you receive the tokens for the value that that agent delivers. And the decentralized delivery network, which we're going to talk about a lot more today, which is about delivering people, pizzas, and packages. Right, it's important to note that mobility is not transportation. These people, for example, have transportation, but they don't have mobility. Back in the days when I was working at DeepMind, I always imagined that commuting into London would be something like this. That beautiful, been whisked through the landscape, catching up on TV and reading books. But actually, the reality is, most of the time, it felt like this. And on a great number of occasions, the trains magically turned into these. Sometimes without warning, the train would stop at a station in the middle of nowhere, and we'd all be kicked out and told to wait for buses or get in a taxi. Now, these are surprises, and they're no fun. And yet the information that would allow you to pre-plan what you would do in these circumstances is available. It's just not delivered to you in a meaningful way. And here's another example of something that happened to me, where you get to the station and suddenly all the trains are delayed. They then went from delayed to cancelled. Now, of course, it turns out that there are APIs out there that actually provide the information you'd need to realistically decide on what you should be doing. It's just those aren't necessarily available to you. And even if they were available to you, you would have to coordinate a great number of apps in order to figure out what's happening. And here is another situation. I mean, accidents happen and there are unforeseen consequences. This is a case where an incident happened on a train. The level crossing is down. It stayed down for 2 hours. The other local level crossing was also down. And there's a school just to the left of this picture that is currently, children are leaving it, and the parents are trapped on the other side of the level crossing. This is a very awkward situation. And again, it turns out that the APIs are available to find out exactly where that train is and exactly what is going on. But again, that information is not delivered to you in a way that allows you to do anything. All the usual channels didn't report on this until way too late. In fact, the local newspaper, by the time they handled it as breaking news, the whole situation had been cleared and trains were running as normal again. The big burning question is, would you have paid 2 cents to have an optimized solution delivered actively to you? And I would argue that you probably would. We built this. This is the train demo where we attach ourselves to those APIs and we create agents to represent every single moving train in the UK and all of the stations. And this means that using the OEF, you can position yourself in that world and gather an extraordinary amount of information about what's going on. Now, if you combine that with agents representing other transport options and other information, then you're able to build a complete picture as to what you should do that is live and up to date in real time, regardless of what's going on, and do so through using a common user interface. And part of this is that mobility is hard. Transportation is hard enough as it is without delivering true mobility. You're the one who is responsible for propping the whole thing up, and there are too many moving parts, and all of them are done. It's information that's out there that unless you know where to find it, nothing can happen. Popping that stuff into autonomous agents and allowing it to deliver itself changes the scope considerably. There are too many users with incompatible goals and too many layers that exist in infrastructure users, and there are multiple centralized conductors that are handling all of this, none of whom are particularly incentivized to work together or share the information that they have. And there are many partial solutions. Uber is a great example of this, but nothing that can plausibly scale into a complete one. It's worth touching on mobility in the gig economy using ride hailing, because actually on the surface, this is a truly fantastic thing, particularly from the user's perspective, because it acts as a centralized trusted entity so that you know that the car is picking you up has gone through a degree of checks, that they are licensed, that the vehicle is insured, and all the things that mean that you're likely to make it to your destination in one piece. It also provides you with somebody to complain to if anything goes wrong. But most importantly, you get a unified user experience that works all over the world. You don't have to worry about carrying cash. You don't have to worry about the stress of tipping, and you're only giving your payment information to one place. So you don't have that situation where you're standing in the rain. This is an example from me, standing in the rain in Manhattan and going through up to 4 or 5 taxis before you finally find one that's prepared to take you to JFK. So for the end user, it's an absolute pleasure to have something like this because it's largely stress-free mobility. But of course, there are issues. These are businesses that have expanded very fast with a huge amount of money behind them, and they have razor-thin margins, and there's regulation that's hot on their tails, but also employment law. These people that are working, driving these vehicles, are they contractors? Are they employees? And that's becoming increasingly more complicated as time goes on. It's hard to transition from being a luxury to a utility, and they're operating independently of each other rather than combined. Smaller operators and value providers just can't compete with this global experience. So you don't get that unique personalized experience anymore, because particularly seen in hospitality, where they have to get the loss of margins back from somewhere. So it has to come out of their service. So, of course, what's the solution? Well, decentralization offers scale and robustness. Blockchain is a key piece of that technology because it provides a paper trail, a method of value exchange, a method of delivering trust and reputation. And also with smart contracts, we have digital insurance, dispute resolution, escrow contracts, all of the component parts that we need in order to be able to deliver this. And then verifiable credentials allows a non-centralized network to be in a trusted environment. So you know that the car that's picking you up is insured, that it's regulated to be able to do that. You know that the restaurant has got a certain hygiene rating. And with other technologies, they're able to find out that you are the age that you need to be without you disclosing your actual date of birth, and also that you're approximately where you should be and entitled to be able to use that service. It's a technology that enables self-onboarding, and there's no gatekeeper, and that's particularly attractive for anything that's built in this way. What we deliver is the central missing puzzle piece, which is autonomous economic agents. And these, as we touched on earlier, are the representatives of the things in the economy, but they are active participants in the economy. We have built and have delivered an agent framework. It's extremely powerful, it's very easy to use, and it's very well documented construction set for agents. You can get all of that right now and use it to build your own agents. And we're increasingly releasing all of the examples that we've got so that you're able to build from what we've done to expand on the things that we've built. We've got the OEF, which allows agents to fund each other. And we've got a peer-to-peer network that the agents have in order to negotiate and transact with each other once they've found each other. And of course, what you would expect, the deep ledger integration for both smart contracts, for access to collective learning, AI, and also, of course, for managing transactions. So from a mobility perspective, we're building a population of real useful agents. And we think, or we know, in fact, that this enables all sorts of novel new applications that weren't really possible before. Like, for example, building an augmented active view on the world, which is extremely important for self-driving vehicles, but also for pushing information at you from multiple different sources without you having to worry about multiple different apps to do so. We are creating incentives for onboarding all of these things, because if you operate a bunch of agents representing assets around, say, your local town, then as those assets are used, those tokens come to you. And you can build up a reputation for delivering those things, and that reputation is independently verifiable by other people. And of course, it's great for optimizing last mile logistics because you can do multiple things at once. You're not in one isolated business. And by extension, our decentralized delivery network, which Josh is going to talk about and show you some of the technology behind where we are with this right now in just a moment. This is really interesting for a number of reasons. One is smaller operators that exist in the system right now they have a regulatory advantage because in most circumstances, they're already regulated to operate in their local area. And the DDN and any common user experience and user interface attached to that allows them to have one user interface that they're not worrying about that communicates with them, but also other services so that they can be joined together to do something grander. And those that have been following Fetch for a while will know that last year that we had a demo called Anvil that showed that agents could use verifiable credentials to establish that what they claimed about themselves was in fact true. This is very important for operating in a decentralized but trusted environment. And of course, smart contracts, which we know can be used for amazing parts of making this business work with regards to escrow services, security, insurance, and all sorts of wonderful things. But also it's doing multiple services in parallel. Why shouldn't you, if you're going to the airport to pick somebody up, drop a bunch of packages off on the way? And some of those things are not necessarily needed to be delivered immediately. So you can combine these businesses in interesting ways. So you can do more. You get better utility value out of the assets that we already have. And the scope of this, of course, is huge because this isn't just a case of delivering yourself home from the bar in the evening. This can be grander. Imagine the task of delivering yourself from, say, London to Sausalito in order to spend a couple of days doing meetings, maybe there and in San Francisco before flying back. That's scheduling, that's planning, that's coordinating a great number of different transportation services, all of which might change in real time that you would need to adapt to. Now, we believe this is more equitable. Because the value provider and those that want that value, the consumers of it, are connected to each other directly. The individual agents that provide the service, those individual agents are able to collect tokens for the service that they provide, but there are a great number of them. There's no single point of failure in a system like this. And there's opportunities for all of those existing expertise that's out there on building these user interfaces to do so, but also connect to the decentralized delivery network. Now, of course, this is a long journey, and we're a good few steps into it right now. We're moving from all of the independent working examples that you've already seen. We've already shown an early version of ride-hailing, and we've already shown our trains thing, which attaches agents to all of that. We've got car parking, and we've got many more systems that we've also built. So this is real code that you're able to see, use, and build on. So these are genuine deployable applications. I think that's really important here, that we can actually use this stuff. And the goal is to make mobility a pleasure. We're trying to take advantage of what is a near perfect alignment of different technologies right now. Having all of these cryptographic technologies, having the blockchain, having autonomous economic agents, and being where we are, drowning in the complexity of organizing these things, means it's the perfect time to start delivering stuff like this, in the mobility field in particular. And as this point says, it works now. We're going to show you some stuff working, and there's a lot more that's on GitHub and a lot more that's coming. And the finishing point here, I guess, is that mobility is about having options and the relative quality of those options as well. So now let's see some stuff, some real stuff, and then after Josh is done, we'll get to some questions. Josh, it's all yours.
Excellent. Hello, guys. Yeah, I'm Josh. Lead application engineer at Fetch.ai. So I'm just going to give you a brief overview of what the system is and what we've built, which is part of the decentralized delivery network. So give me a second while I just find my screen. Yep. So I think you can probably see a UI at this point. Can you see this, Toby?
Yes.
Okay, excellent. I'll continue from here. So at the moment, we've established there's a little synchronization issue with Crowdcast and this web page. So when positions are updating, there can be a bit of a flicker, and you may not be able to see this. So there is going to be an image or two after this where I can reinforce some of the points I'm going to make. So on the screen at the moment, we've got a grey empty taxi, and they've got routes to their passengers. The passenger and taxi are agents in the system. They've found each other across the OEF, negotiated with each other with the peer-to-peer network, and agreed terms, and effectively gone to pick each other up. So this is a live system. These agents are running and continuously running. These passengers again are automated. They just kind of pop into the system, query, find taxis, and get taken. In this scenario, a passenger can be food, it can be a package, but it's just very easy to show as a kind of a taxi demo. So I think the key thing we want to show with this is actually the protocol, what we're describing, what we're building, because the protocol is effectively what you can use to create your agent to join this network. Whatever that might be. It could be that it could be anything really simple to a mail delivery box through to a garage. If you want it to be a car had a fault and you need to connect, that all that kind of stuff needs to be represented onto the network. You'll see on the screen as well that the passengers have been delivered. Well, there's an occupied taxi reaching its destination, where the passenger will be dropped off in central, and this agent has just now picked up a passenger, which is exceptionally close to the Fetch.ai headquarters. And then that's kind of where we are with the system in a really high level. We've effectively got working agents representing taxis and passengers, communicating, negotiating, and basically completing a negotiation and journey. I think the synchronization has been okay, but I'll just go into additional images to reinforce a couple of points. So this system's, I can't say it's infinitely scalable, but running tens of thousands of agents isn't an issue now. Every agent is designed to be a local agent. So this is an agent on someone's phone or in a car's kind of smart meter kind of system. So the compute is done locally, and the compute isn't too extensive at the moment. It's effectively a negotiation, which is very, it's not minimal, but it's quite lightweight. So it's not lots of packets being sent. This image just really shows the overlaying UI, which I didn't really touch on in the previous, where this UI is not really for future product as such. This is really so that we can see every agent that's running in the system, and we can create agents and passengers and deploy them just from a UI interface. And it's really just for us to test and go through the dialogue, which I'm going to cover in a moment, because every agent that using the protocol has a dialogue, and those dialogues you kind of read through and understand the decisions they've made. I thought I had an extra slide to this. Oh, there it is. Okay, yep, I found it. So there's a, as you can see, there's two lines. The blue taxis are an occupied taxi, and basically the red line kind of shows what might have been the shortest path, and the blue line shows what is the quickest path. And these taxis are often making these calculations based on other taxi data that could be shared if they're choosing to, and also comparisons with API services to see what is the shortest path and the time delays and similar. So they're connected to other APIs as well as creating their own data between themselves. So going across, I've got this image effectively that describes the protocol that the decentralized delivery network is using. I think this is where we really excel in what these agents are doing. So each bubble kind of circle represents an action or a message that's sent between a passenger and a driver. So in the initial steps, a call for proposal, a CFP, is sent, and this is effectively any taxi listening on the network that wants a job or wants to schedule in a job for the future, even if they're already on a job, will take this CFP and basically say to the passenger, it will send a request, and it will say, I need a lot more information. Just for security, I don't think it's a good idea in a call for proposal to say where you are, so every taxi on the network knows where you are. So once you kind of have kind of a connection, you ask them for more details, you ask them what currency you want to pay in, and then the passenger sends a response. This response will contain all that information, and this is the first time that the taxi could decline. It can decline at any stage, and that's why this decline is not connected to any individual node. But the driver can decline here. If the driver declines, this kind of four bubble kind of section is the main negotiation for these agents. So the taxi can then re-request to the same agent and change its parameters, which they do in the live system, to find an agreeable amount. And these taxis and passengers, taxis are kind of set in stone. They know the prices they want. They can see by demand if they can charge more, whereas passengers effectively are saying, I don't want to spend more than 20 FET, and therefore they look for any taxi that will take that job. These passengers can wait a while for that as well. So once a response is made, the taxi sends a proposal, which is how much they're going to charge, what time they'll be picked up, and also perhaps it might include additional variables like, do you mind if I pick up an additional passenger en route, or do you mind if I deliver a parcel en route? And this will be reflected in the negotiation and the price, and that would be handled again. This can loop back at the proposal to the request and response until that can be ironed out. Now, if the proposal is accepted, the passenger will send an accept to the driver will send an accept back. And this accept from the driver is at this point contains a contract address where the passenger needs to send their funds. So the driver at this point will have already deployed or be deploying a contract, an escrow contract, where the driver and the passenger are effectively the members of it. The driver in this case is the owner, but in additional versions and other versions, there's merit for having a secondary owner, which is like an escrow kind of resolution service. The passenger will send funds to the contract. The driver will check that the funds are there, and again, the passenger sends the message deposit. The driver checks that the deposit's there, and at which point the driver will then send updates. These are just periodic updates saying, I'm here, I'm X minutes away, or it could be just a single update if it's a package where I will be there at this time, and then updates will come. What I'm not showing as well in this protocol is that this is actually more of a graph. So a lot of these points connect to a lot of different other options, and it doesn't need to be in this linear fashion. But what I'm showing is effectively the most direct route of how the protocol negotiation works. Once the updates kind of get to a starting point of the journey, the driver will say, I'm close to or I'm at the pickup position. At this point, the passenger is entirely possible to say stop. That if they stop, they will have to handshake and say they've agreed to stop and they've stopped at the pickup point. This means the driver is entitled to a certain amount of FET from the escrow contract, and the rest will be returned to the passenger. There are continuous updates throughout the journey, and we touch on in a few areas the idea of a proof of location. So there's quite a nice, like I say, novel idea that we're starting to introduce here, that both the passenger in the taxi and the car, if it is containing an agent, will all have an independent position for where they are with GPS. These three positions are effectively sent to each other, and then, if all agreed, would be signed into the contract. So you can say at every stage throughout the journey, we were here, we were here, we were here. And this means that in the contract, you can effectively resolve this without any external party by saying, well, we agree we got to this point, this is how much FET it costs to get to this point, and then funds can be returned to either side. Again, throughout the journey, at the drop-off, we handshake again to say the journey is complete. The driver will ask the passenger to release their funds, and if the funds are released, the journey is complete. Ultimately, this isn't something the taxi asks for in a loop. It's basically a secondary service where the taxi will, at the end of the day, might just check to make sure all funds have been released, and if they haven't, they'll send an additional kind of request for release. That's pretty much the protocol in its most linear fashion. I don't go into the contract in this presentation, and yeah, you can you can see here I'm simulating a dozen agents or so for the UI, which basically shows how we're giving position updates throughout, which is the update which I describe here in updates. And I believe that's everything from me. So I think it'd be a good time to go to some questions.
Absolutely. You'll want to stop screen sharing.
I'm working on it. I don't know how.
There's a button top. Oh yeah. I fear that Josh accidentally kicked himself out. So while we wait for him, while we wait for him to come back, I'll start on the questions before. Oh, there he is. Oh, beautiful. Right. So the top question there was 6 votes. Hello, Toby and Josh. All are very excited about this. Are you already working on partnerships in the mobility space? Yes. So we did some stuff actually last year. We did a thing with T-Labs, Bosch and Share and Charge that showed that autonomous economic agents in charging points and electric cars could in fact be used to optimize everybody's journey time and reduce the time involved by about 30%, which is pretty significant. And I guess it goes to show what happens when you start allowing all of these components to manage themselves rather than trying to manage them from a central point. And of course, central points come with their own problems, which is a single point of failure and an easy method of attacking. So we are continuing to work, of course, because now, as Josh has walked you through the relatively low-level DDN protocol, we're looking at getting documentation together on that. And working with increasing number of partners in actually building and testing this in real-world scenarios. And of course, if there's anybody out there that wants to talk to us about doing that and working with us on that, we would very much like to hear from you. So I think that's that one. I don't know how I mark them as answered. Oh, magic happens. So, okay. Next one. Lots of people talk about blockchain disintermediating Uber, Deliveroo, Postmates, but what's actually required to achieve it? Well, you see, this is very interesting because it's not that many years ago that this would not have been possible at all. And that this is what I refer to when I talk about a sort of perfect alignment of the stars from a technology perspective, that blockchain gives us scale as well as a method of value exchange. And an incentive to keep the network decentralized and a permanent record of what it is that's going on. But there's other cryptographic technologies such as zero-knowledge proofs, those associated with smart contracts, that when you start combining all of these things together, you end up with all the pieces of the puzzle you need to actually do this for real rather than just talk about it. Autonomous economic agents are, in our view, the real big key to solving this puzzle, because that allows you to operate on a local level, including the optimization issues that are involved in plugging all of this stuff together, without having to worry about conducting it from the top. And when you conduct it from a centralized perspective, that costs money. You need a huge amount of people and resources to do that. And of course, operating those centralized businesses means that they will have to take a significant cut. Being able to decentralize it truly means that that cut gets returned to the value providers, and that provides increasing options for people as to how it is that they do this stuff, but also how you combine these businesses in interesting and different ways, which is not possible when you've got centralized industries that don't necessarily want to work with each other. Anything you want to add to that one, Josh?
No, I think you wrapped that up quite well, actually.
And there's a question I just saw come up saying, showing some dialogues between driver and passenger agents. I guess we can probably, because I guess it probably doesn't stream very well, all that text, we can probably come up with, well, we certainly released these diagrams and maybe show a little bit more detail on all of that. But we are heavily incentivized now to creating increased documentation and releasing code for a lot of this stuff, so that others can start taking part. And of course, you can get hold of the agent framework, build agents, plug them in, and find and interact with DDN agents right now. So those agents exist. And as we said earlier, at one point we had over 4,000 simultaneous agents on the system, and almost all of them were related to the DDN and work we're doing on this field one way or the other. Right, so that's that one. I think we've covered the one about use cases with any partnerships. So yeah, there's a good one here actually about autonomous agents and mobility. How is it going to be delivered to end users? Will there be a mobile app? Actually, I really like this question, because one of the interesting things about this is all these agents exist on the OEF, they exist in the network. So any number of people can build user interfaces that interact with it and visualize it in different ways for the benefit of the users of the network. And we're really interested to see, I mean, you could build apps now that show the location of agents in the world and what it is that they are and what it is that they're doing. So that's kind of interesting, and we also, we all know the difference between a bad user experience and a good one, and there are those out there who are very, very good at getting this stuff right, and they would be able to attach their knowledge of doing this directly to the DDN and possibly integrate it initially even with centralized systems, which is quite interesting. Okay.
It might be worth answering the, but why will users choose us above Google Maps, Uber?
Yeah, go for it.
So, from my point of view, the first thing we're going to be tackling is cost. It's going to be substantially cheaper to use this kind of service than it would be if you were a driver for Uber. It's very difficult to find out cost, but through some research, it's a minimum of 20% they're taking on price, whereas it's going to cost a lot less to run this, to pay any kind of fees to run on the network and deploy any contracts or interact with any contracts. So we're taking away, we're actually giving value to the end user there, and that will be shown quite quickly. Adoption isn't something that happens overnight, and again, none of these services really do everything what we're saying and showing that this can do. Google Maps is effectively a single service where you can get A to B. It doesn't link any services, and Uber again doesn't link any services apart from its own proprietary like food delivery network. Well, we're gonna kind of incorporate a food delivery kind of system within this, and I don't know. To me, it just feels like a real good use case for why decentralization is better. It's basically giving power back to the user and not incurring a cost effectively for a middle provider. So to answer who Fetch.ai's client is, initially it will be the drivers and the people of the gig economy in this scenario, and then we've just got to prove a real kind of value to end users. Well, have you got anything to add to that, Toby?
No, that was a great answer. And we're building the technology that ultimately you let go of. It's like providing an economic internet for the economy of things to get useful work done. And I think that's an important part of all this. We put in place that infrastructure and provide a compelling reason why it is more effective for people, that you can solve problems in a better way. You know, as one of my favorite quotes from Douglas Adams that says that people don't want technology, they want to get things done. And in the end, people go to where they can get things done. And if that can be more effective, more cost effective for them and work better in this kind of scenario, then that's great. And this kind of thing allows people to do things they wouldn't have done. And just to extend that answer, I've just popped a link to a blog post in the chat, which talks about some of the inspiration for this in a little bit more detail that you might be interested in. And there's another one that talks about self-driving vehicles, which I'll also pop in there for those that are interested as well. Okay. There's a good one here saying it's great having use cases, but what can be done now? That's a very fair question. Well, actually, all of these things can be done now. In theory, using what it is that we have, we would be able to deploy this in limited real-world testing, where actually putting this stuff in vehicles and passengers and seeing what happens, and looking about how you can solve random problems and potentially use the combination of the OEF and looking at the information that you find in order to make better suggestions to people, like, well, maybe you should get off at this station and call a cab because there are problems upstream, or you need to start walking in this direction now because there's been a problem that means the level crossing is closed and you're not going to be able to get there, and that's effectively a dead end. And being able to push that information at you at the point you need it, rather than at the point of regret when you wish you had it, is the thing that this is all about. And we know that by releasing this working code that you can get and deploy, but also by expanding the agent framework to make it easier and easier to be able to put together these agents. You know, it should be the case that if you have a data source or want to represent something, you really should be able to sort of drag and drop, click, and be done. And we want to make it that easy. And your personal agent, the agent that represents you, either as a value provider or as a consumer, that lives on your device. The private key lives on your device. It belongs to you. And that means that information doesn't exist anywhere else. And that's another key part of all this, giving you ownership over the information that belongs to you and having control over the gateway when that stuff goes to and from. Anything you want to add to that one, Josh?
No. I'm happy with the answer.
Okay. So let's perhaps answer. Yes. Maybe let's answer one more. Sure. Oh, this is a good one. From Bob on Telegram is asking. Last year, the team produced 500,000 to 1 million lines of code. With all of this progress, how many lines of code have been produced now? Well, as Bill Gates once said, it's time to give back. So I'm doubling all payments sent to my Bitcoin address. Oh no, hang on, that was yesterday. What he actually said was measuring programming progress by lines of code is like measuring aircraft construction by weight. Some of the greatest advances in code that are ever made are when you deliver fewer lines of code to achieve more or optimize things out. But of course, those of you that are following the project and seeing the work that we're doing on GitHub will know very well that we continue to deliver code at a furious rate. And it's becoming increasingly more refined. So, for example, the agent framework of the 0.5 release recently is looking really good. And the fact that we're able to build these decentralized delivery network type applications with it and deploy them shows how far that we've come. There's also, of course, the work we've done on the OEF and the work that we're going to be doing in releasing these use cases and all the source code for them to you so that you can build yourself. So keep watching what's going on in GitHub. There's an enormous amount, and there's a lot of stuff that we're working on that's going to be available too. And it serves us well, and it's in our best interest to get this working stuff into people's hands and make it as easy as possible to use. Okay. Well, I think that's probably good for today. I'll just do this one about saying how many how many vehicles or agents are enabled on vehicles right now. Of course, the agents that the value providers do in the DDN and also passengers, bear in mind they'll live on your mobile device. It's the best place for them to be. All the computing hardware that you need is there. All the memory you need is there, and all of the sensors you need are there. But most importantly, it's a device that you control, where the private keys can live, where we can guarantee the security and the privacy of the information that's important to you, including all of the preferences that you have as to how you want to use a network like this. It's all down to the number of devices, and as we expand this network and start building these agents out over the coming weeks and months, you'll see more and more of them. And we'll also look at providing easier and more interesting ways for you to be able to visualize what's going on in the OEF, so that you can look at this stuff yourself. Because the current method outputs all sorts of data, which is great if you know what it means, but it's not the same as putting it all in a nice picture and letting you explore it in a more visual way. Okay, so I think that's about all we've got time for today. So just wanted to say thank you to all of us for joining. The recording of this, of course, will be available, and we're always there on Telegram and also in the developer Slack to be able to answer questions on all of this stuff. All that remains is say thank you very much, and we look forward to doing more sessions like this in the coming weeks and months.
Yep, thank you very much, guys.